This is 9/11 Freefall.
Good evening, ladies and gentlemen. Welcome to another episode of 9/11 Freefall. My name is Andy Steele, and I am the host. Tonight, we'll be providing an update from Dr. Leroy Hulsey himself on the progress of the World Trade Center 7 study currently underway under his supervision at the University of Alaska Fairbanks. This is an update that a lot of people have been waiting for. We got it tonight. That'll be coming your way this evening. I'll also be going over some articles from AE 9/11 Truth. And hey, this is our 9/11 episode for this year. I'm probably going to have to do a rerun next week. We're going to be so busy at 9/11 Justice for All. I'll be talking about that tonight as well. So all that is coming your way in just a moment. Stay tuned.
The views expressed on this show by guests and the host on issues outside of the 9/11 controlled demolition evidence are the opinions of those individuals alone and do not necessarily reflect those of architects and engineers for 9/11 Truth.
All right, welcome back to the show, folks. So the interview with Leroy Halsey will be coming up. It's only about 36 minutes long, basically just, again, giving you an update on where they're at, the progress of the study, and some of his findings as they stand right now. Last week, I covered an article written by Ted Walter about the battle taking place at the Europhysics Journal and Europhysics News, and this involved the publishing of the article by AE 9/11 Truth authors at that journal a few years ago, and Zdenek Bizant's and Jia Liang Li, their response to it not too long ago. And I don't think I got to the point in the article that Ted wrote where it talks about Tony Zambodi and Dr. Robert Corral's letter to the editor responding to Zdenek Bizant. So, as Ted wrote in the article, in February 2017 issue, Lee and Bizant's article was published. Unfortunately, at that point, the open discussion that the editors had said they hoped to create came to an end. Corral and Zambodi submitted a letter pointing out a number of errors in the Lee-Bizant article that were characteristic of Bizant's work on the World Trade Center failures. But the editors declined to publish this letter on the grounds that they had already presented the subject fairly and that differences on technical points could be substantiated in other scientific journals. So they just cut short the debate, didn't want to hear any more about it, gave the official story the last word despite the numerous problems with Lee and Bizant's article. We'll be going over that here tonight briefly, but they don't want to hear any more about it. They don't want to be touching this controversial issue any further. Two very different views of an important topic. Obviously, it hasn't been resolved, as we'll be going over here. But what purpose is there for a scientific journal if not to debate and discuss these important topics? So, as Ted's article continues, a year and a half later, we are publishing the Corral and Zambodi letter to the editor here at AE911truth.org. While this probably marks the end of Europhysics News' chapter in the world's quest to understand what happened on 9/11, I have a feeling the debate on the World Trade Center failures is just beginning to heat up. So Dr. Corral and Tony Zambodi published a letter pointing out the problems with Lee and Bizant's paper. We're going to go over that letter here today. Again, this is by Tony Zambodi and Dr. Robert Corral. Title is A Response from the Lay Critics, quote-unquote, regarding mechanics-based mathematical studies proving spontaneity of post-impact World Trade Center towers collapse. The letter starts, Jia Liang Li and Zdenek Bizant begin their article in EPN 48-1 by claiming that, quote, lay critics have questioned the cause of the collapse of the World Trade Center, quote, without any meaningful calculations, end quote. As co-authors of 15 Years Later on the Physics of High-Rise Building Collapses, the article to which they were responding, we must object to that label and point out the fatal errors that are characteristic of their body of work on the World Trade Center failures. To claim that we are, quote, lay critics is insulting and unprofessional. Dr. Robert Corral is a professional emeritus of civil engineering at McMaster University in Hamilton, Ontario, and a fellow of the Canadian Society for Civil Engineering and of the Engineering Institute of Canada. Anthony Zambotti is a mechanical design engineer with 25 years of structural design experience in the aerospace and communications industries. We have each published articles in respected journals critiquing these authors' analysis of the World Trade Center failures. And that is such a great point. You know, to just dismiss two people with credentials to know what they're talking about. It's called them lay people. Only people advocating the official story side of it can get away with that. What's funny is that you'll turn on corporate media and you'll see all sorts of lay people dismissing the people that question the official story, propping up the official story. I mean, people from Popular Mechanics who have really no scientific background other than being editors of a science magazine. That doesn't necessarily qualify them. People like Davin Coburn who just go out on the radio and outright lie about seeing pictures of World Trade Center 7 scooped out. That's provable now. And they get held up as people to listen to, while people with actual credentials who oppose the official story get dismissed. And the people dismissing them, writing these things, get away with it. They get a free pass. I mean, if we had done something like that on our side, they probably would have rejected the paper outright just on those grounds and how unprofessional and immature that is. And it's not even factually accurate, as was just pointed out. Again, they have the credentials to know what they're talking about. The errors in the present article are so numerous that we cannot cover all of them in this letter, but we will highlight the most important ones. Number 1, readers should not be misled by the statement on page 19 that says the first simple analysis, 2 and 3, with a simple mathematical proof, emphasis added, of the inevitability of collapse was published soon after the collapse. This is simply wrong. There was no verification whatsoever. It was only a prediction, and ultimately an inaccurate one at that. The ratio of potential energy to column energy absorption claimed in that, quote, proof has been shown to be a gross overestimate which resulted from the author's use of A, free fall acceleration during the fall of the first story instead of the actual measured 0.5 g acceleration. The latter gives a velocity at impact equal to about 75% of the velocity caused by free fall and thus reduces the author's estimated kinetic energy by about 50% due to the squaring of velocity in the kinetic energy equation. B, maximum allowable service load of 58 mkg for the falling upper section instead of the actual service load of 33 mkg. The latter further reduces the estimated kinetic energy to about 28% of what the authors predicted. And point C, column energy absorption capacity as estimated by the authors at least 3 times less than it actually was. The authors speculate, and this is point 2 in the letter, the authors speculate on fire spread in various floors without citing evidence and then make the outrageous and unsupported statement, second column of page 19, this is the quote, a mere half hour of heating above 150 degrees Celsius would have been sufficient to cause marked viscoplastic creep of the structural steel used. Who has ever heard of steel that loses strength when subject to just 50 degrees more than the boiling point of water? Point 3 in the letter. The authors make yet another unsupported statement in the next paragraph. And this is what they said. In consequence, many steel truss girders likely separated, emphasis added, from the columns and beams, especially during the cooling phase. When floor trusses, beams, and girders are heated, they expand first and then return to their original length afterwards. Unless they buckled, they would simply push their end restraints outwards and return to original length after cooling without separating from their end restraints. Number 4, structures such as the World Trade Center Twin Towers are designed to have a factor of safety of 3 or more in order to allow for extreme loading conditions and a possible shortfall in nominal strengths of structural members. Lee and Besant, however, omit several facts that are pertinent to understanding the redundancy of these structures and their ability to withstand the loading conditions experienced on 9/11. And here they are. Letter A. They do not mention that only a relatively small number of perimeter columns were actually damaged, approximately 15% of the 236 in each of the Twin Towers. Letter B. They do not mention the 47 extremely heavy columns in the 135-foot long by 85 feet wide central core structures, which were some 60 feet away from the impact surface. Letter C. They do not mention that the alleged initiating failure of World Trade Center 1 supposedly occurred on the opposite side of the building from the impact. And letter D. They do not mention that the horizontal propagation of the collapse of World Trade Center 1 occurred across the entire building in less than 1 second. Point 5 in this letter. In the article cited in reference 6, Lee and Besant attempted to refute the argument that the lack of measurable deceleration during the fall of World Trade Center 1 indicates that it was not a natural collapse. In that paper, they used an average 14-inch square box column for all 287 columns with a common yield strength of 0.248 GN/m squared, and they say the total column cross-sectional area is 6.0 m squared, which puts their 14-inch square columns at the 15.5 mm wall thickness. They then show the actual yield capacity is 2.84 times greater than the static load, which would provide for a factor of safety close to 3. However, when doing the calculation for column energy absorption, they err by using a yield moment value of 0.32 MNM, which is that found for a 14-inch square box column with a much thinner 6.75 mm wall thickness. This markedly decreased the column energy absorption they used and is inaccurate. And finally, point 6, the mathematical model that Lee and Besant present is based on 2 differential equations that refer to articles cited in references 3, 4, and 5. We have shown in our work that the plastic hinging assumed in the pulverization of concrete result in energy dissipation that far exceeds the values that they use in their equations involving force F(c). The above points provide some insight as to why the simple explanation given by Lee and Besant is inaccurate and thus non-explanatory, and why additional investigations into these collapses is needed. Signed, Dr. Robert Corral of Canada, Anthony Zabodi of the USA. And look, folks, there's a lot of technical jargon in there, but I just want you to ask yourself, does it sound like the debate is over? Does it sound like there is not more to be said about this issue? But Lee and Besant aren't going to have to respond to this letter because the Europhysics News will not publish it, just dismissing it outright. So we got to do our work in the truth movement so that people like Dr. Robert Corral and Tony Zambodi can be heard. The media is not going to do it for us. We got to do it for them. That is our role here. Their role is to argue these points. Our role is to give them that opportunity to do so. Find ways to get this information out to as many people as possible. So I wanted to get that out here on the air. I also want to get this out onto the airwaves tonight. There was a bulletin that went out from AE 9/11 Truth, and I'm just getting my papers straight here. The title of it is The New Bobby McIlvaine Act Campaign, Make It Go Viral with this September 11th. It says, today, as we approach the 17th anniversary of 9/11, we are honored to release our new Bobby McIlvaine campaign ad. Based on our 7-minute video, 9/11 Father Seeks Justice, which now has nearly 2 million views on Facebook, this brand new 37-second spot will be our primary vehicle for raising awareness of the Bobby McIlvaine Act during the upcoming 9/11 anniversary, when everyone is thinking about 9/11. Earlier today, we released this powerful video on YouTube. On the morning of September 11th, we'll release it on Facebook, and it is very powerful. It's cut from scenes from the 7-minute video, It's got some music added to it, really gets your attention, really drives home why this is important because of people like Bobby McIlvaine who perished on that day. So many others lost their lives over something that we know we are being lied to, that we have not gotten the full story. Evidence has come to light that these buildings were brought down in controlled demolitions. For me, the debate is over. This is what happened, and more people have to hear it. So we got to pass this video around, show it to as many folks as possible. And the great thing about a 30-second video is that it's quick, it gets in people's heads, and prompts them to look into the issue further. But it grabs them with that emotional message, which is what they need to hear, because we do lose sight of the fact that this was a horrible tragedy, and there were actually lives that were lost, lives cut short instantly without any expectation that it would happen. Like so many people, when you pass away on a given day, not knowing it's going to be your last. And you shouldn't have to have that happen to you when you are so young. Terrible tragedy. But the article continues, we're asking you to do 4 things to ensure that this video goes viral. Today, donate to our September 11th Facebook ads. In addition to releasing the regular Facebook video on 9/11, we'll also run it as a paid ad. Our goal is to reach 5 million organic views and 5 million paid views. With just 10,000 in donations, we can achieve the latter goal. That means that you yourself can reach a whopping 10,000 people with only $20 donation, or 100,000 people with a $200 donation. So please help us raise $10,000 by September 11th to bring this video to 5 million more viewers. Then it says, today, share and embed the YouTube video. While the Facebook video is likely to receive the most views, you can also help us make the YouTube video go viral now. Embed the video on your website if you have one and forward it to everyone you know. Here's the YouTube link, and it gives you the link to the video. And then on September 11th, this is what's coming. This is what you're going to need to do that day. If you do nothing else, if there's not even a moment in which you can spread awareness of the controlled demolition issue, the 9/11 issue on September 11th, this is what you can do. As soon as we launch the Facebook video on the morning of September 11th, we need you to share it. Don't worry, we'll send you a reminder that morning. Folks, sharing something on Facebook is the simplest thing that you can do. It's 2 button pushes. Push to share. It prompts you with a question of who you want to share it to. Select your friends. Select everyone. Bada bing, bada boom. It is up. You can even write a quick message. Hey, everyone should watch this. Very simple. Then you go to work, move on with your day. Hopefully you come back in time to watch our events at the Capitol, which I'll be talking about very soon. The article concludes, on September 11th, send the YouTube video to your members of Congress with our new pre-written email. On September 11th, we will have a new pre-written email for you to send to your members of Congress. The new letter will invite them to watch the half-minute Bobby McIlvaine campaign video and urge them to finally introduce the act. Again, we will remind you. And then there's a PS at the bottom. In case you didn't know, we'll be in Washington, D.C. on September 11th for 9/11 Justice for All. Please send this event link to your email list. A huge thanks to our tens of thousands of supporters for making these actions possible. And we got some of the best supporters in the world here at AE 9/11 Truth. We put out a challenge to our supporters to make appointments with their members of Congress to try to get them for the time period around the 11th. And so many people are doing it. There's just so much coming in, so much planning going on. And God, so many people coming together and doing this important work, taking the time out of their busy lives. There's almost something divine about that. And it's not just this September 11th. All right, it's been going on for years. I've seen this. People would go to Ground Zero, stand there, and not protest so much as just have a presence at the place. And then there would be events happening and speakers, and there's always that going on every year. But the fact that so many people come and do it, there's just something magical about that. So many people care. I remember the first time that I discovered that other people were doing this. Seriously, when I first started doing this, I started very slowly with a MySpace page, and I thought I would be the only person doing this kind of outrage until I found the first other 9/11 truth activists, and that led me to finding others, and I came to find out, wow, thousands of people are doing the same thing. Seriously, it's not like I saw somebody doing it and decided to do it. I did it on my own. And that's the story of so many other activists out there who, on their own, thought they were going to be a lone voice in the wilderness, and then it's like, oh my God, here's all these other people. Now I'm part of a community. Now I'm part of a movement. So that is excellent, and we just got to keep that up. Look, our story never changes. Our evidence never changes. It's not because we're clever. It's because we are right. So all we have to do is be steadfast. Keep in mind that in history, nothing changes overnight. This is just the way things go. The other side will shoot themselves in the foot in the end, because that is what those people do. And the public sees through it now. Everybody is coming awake to the fact that there is a problem in the United States. Now, some people may focus on other issues. We focus on the 9/11 issue here. But they're coming awake to this fact, and I really think a change is coming. Somehow, some way, there will be a change, and when that happens, the Bobby McIlvaine Act will be ready to go to get passed, and we'll finally have an acknowledgement of what really happened that day. What can you do in the meantime? What can you do this September 11th? If you have the time, if you have the vacation days from work, if you can travel, we want you there. 9/11, Justice for All, Washington, D.C. We got a whole day of events going on that you can be a part of. It's happening again on the anniversary. It's going to be starting at 10 o'clock that morning for those early birds, which, I don't consider that early. I get it pretty early in the morning. But we're calling it early. And if you want something to do before the rally, come down to the White House. I'm not exactly sure on the exact spot where I'll be, but, take an adventure. Walk around. You will find us. I'll be there. I'll make a short video, if I can, from the spot. Talk to some people there. And we're just going to have a presence there at the White House as we get ready for the big rally, which is going to be happening at the Capitol on that day, 2 o'clock. West front side of the Capitol, between the Capitol building and the reflecting pool, for our biggest gathering of the year. In addition to the powerful speakers, there will be a reading of statements written by several 9/11 family members, which is the important part in my view. That's why we're doing it, is for those people who died. So there'll be a rally, and then 4 o'clock, we're going to be doing some activism. All right, we're going to leave the rally. We're going to fan out in groups of 6 congressional office buildings, break that up there. You'll pick a building. We'll send you to it, and what you're going to do is you're going to deliver information on the Bobby McIlvaine Act. It's going to be a palm card. It's going to be a letter from Richard and a shortened version of our petition. And we're not going to mess around. We got a lot to do. So we're going to go from office to office. We're going to need lots of people to help out. Soldier up, take on a wing of these office buildings, and just walk in and hand it to the receptionist. Say, you got to pass this on to the congressman. We want an answer. We want to know if you really care about justice, if you really want to resolve these issues. Many Americans have passed the Bobby McIlvaine Act. And then once we've done all of that, we're going to have an event from 6:30 to 10 p.m. Busboys and Poets. All right, and as the article says, you're going to join us at the Brooklyn location of Busboys and Poets for an evening of truth-telling and music, headlined by singer-songwriter Jordan Page. I'm really excited about that. I remember watching Jordan Page at other types of rallies, and I really like his music, and the fact that we're able to get him is a real coup in my book. It's going to be a $15 admission or $25 at the door, and it's going to go towards the cost of the space and travel expenses for the speakers. Doors open at 6:30, event gets underway at 7, leaving a half hour to get settled and order food and drinks. Yeah, you can get food and drinks here too. That's going to be really cool. The address is 625 Monroe Street, Northeast, Washington, D.C. I don't know if you need the zip code when you're looking up a location to go to, but the zip code is 20017. And it says, please consider making a donation to help us cover the considerable costs of the Capitol rally and travel expenses for our speakers. So there you go. It's a full day of events, a way to get to know us. Come up, let us shake your hand. I know you're out there. You're the foot soldiers doing the work to get this message out. So please come if you can. And if you can't, you can watch our live stream on the day of the event. Go to ae911truth.org and view it. I'm going to actually be announcing it, so you're going to be hearing this voice a lot that day. Richard's going to MC the events, but I'll be there for the viewers at home. Big stuff going on this September 11th. Please be a part of it. Spread the word. Let other people in the movement know what's going on in D.C. on that day. All right, my interview with Dr. Leroy Hulsey is coming right up. Dr. Leroy Halsey got a B.S. in Civil Engineering in 1965 from the Missouri School of Mines and Metallurgy, and an M.S. in Civil Engineering from the University of Missouri at Rolla in 66. He did postgraduate work at the University of Illinois at the Ph.D. level from 1968 to 71, and in 76 he got his Ph.D. in Structural Engineering from the University of Missouri, Rolla. He's owned and run 3 high-tech engineering research corporations and has extensive teaching and research experience. Currently, he's the chair of the Civil and Environmental Engineering Department at the University of Alaska Fairbanks. And we're going to be talking about the World Trade Center 7 study today, giving an important update to our audience. He's here to do that. First, Dr. Halsey, I just want to welcome you back to 9/11 Freefall.
Thank you. I appreciate that.
Before we get started, for newcomers, people who may not be aware of who you are and what the study is about, briefly tell us more about yourself and why you decided to undertake this study.
Well, there was one of the members of the Architects and Engineers for 9/11 Truth that contacted me, and he was originally from the East Coast. He is located in Anchorage, and he was looking for a person that could actually conduct research, and so he made contact to me. That was several years ago, and then I turned the opportunity down to do the work, to research work, and so the approach was made again. I turned it down again. The approach was made again, and I put together an estimate of what I thought it would cost to do it, and the dialogue began. And at that point, I decided I was old enough to not worry about whether there could be any consequences to this, so I went ahead and said, okay, I'll do it. So at the end of the day, I began this study for the sole purpose of bringing the truth to what had been done previously and try to explain how this building may have come down or may not have. I may not be able to fully explain it, but we can certainly tell you what didn't happen. And so that's where my goals have been from the very beginning, is to at least establish that pattern. And right now we're close to having everything completed.
Please tell us what the study is, and also tell us what is a finite element analysis exactly for the layman.
Okay, so as a forensic engineer, I would like to take a building that has come down and try to explain every little detail of what may have happened and what may have transpired. And typically you would have the broken elements of the building there to go sort your way through, to have meteorological tests done on the samples, to do all kinds of investigations on various parts and pieces in the laboratory. And then through that process, that's the experimental process. And then from there, you would develop basically a computer model to simulate what that building truly was in the real world. And that is what we often call a finite element model, meaning that we take the system in its entirety and break it up in discrete little pieces and then put it all back together so it looks like the real structure. And a jigsaw puzzle is an example of taking a beautiful picture and cutting it up in all these little pieces. If you put it back together right, it looks like the original picture. That's what this does, except mathematically, we can then begin to look at the stress throughout each one of those little pieces and how they connect to each other and how they respond and work together. And so that's what we ended up doing, is using two finite element computer programs for the whole purpose of being able to understand, as a result of certain effects, how that building might respond to those conditions. And then we also used the two computer programs for the purpose of correlating the results to see if the two models with two different programs were giving us comparable, if not the same results. Also had two PhD students working for me. One of those is still with me. The other graduated, and they did individual evaluations of the same stuff so that we could correlate their thinking with each other. And also, as a third quality control standard, I then reviewed their work. So the process was checked and rechecked to ensure that what we were doing was accurate and that what our interpretation of the results were the same. Now, keep in mind, when I said that initially as a forensic engineer I would start experimentally, we didn't have that option here. We did not have the option of having parts and pieces and crumbles, debris, to be able to evaluate the materials. That just wasn't an option for us. However, what we did use was the erection drawings. The erection drawings and take those erection drawings, which is what the building was built by, and from that create our computer models. But we were not able to correlate against experimental damages that were out there in the field. That was all hauled away before we ever had access to it, unfortunately. And so that is an issue that concerned me. But we feel like what we've done is quite accurate and quite understandable and very beneficial to help you understand what may actually happen here. The building itself, which you haven't seen anything about since I made a presentation on September 6th last year. I haven't said anything since. So since September 6th, we've been working on progressive collapse and those issues. And so at that time, I said very clearly and emphatically that fire did not bring this building down. Since then, we've been looking at various aspects of what the building collapse might look like. And right now, I can tell you without anybody seeing it yet, that I can tell you that if you take our building and put it in a video, beside that, the real building coming down, the two side by side, they look almost identical, which is quite different than what you've seen previously by the analysis that was done by Nist. Their building looks quite different in the way it comes down versus the way the true building came down. Anyway, so at this point in time, we're effectively about 2 weeks from having all of the analysis done on the progressive collapse. We're basically just going through and refining it, and then we will have a report by the end of the year. And the idea there is to try to have sufficient people reviewing our work to provide a peer review of our effort, and that would be at the structural area, perhaps the material side, perhaps the architectural side, and so that we have truly a quality review by the peers. So that's where we are. We're close to being done. We intend to have everything written by somewhere before the end of the year.
Right, and it's impressive work. I know a lot of effort has been put into it by you yourself, by the graduate students, and this is a very important study that is coming out here. I mean, probably one of the most important ones in our century currently, and I'm not overstating it because this is a very controversial issue, and a lot of engineers are not satisfied with the story that we've gotten from Nist. A lot of family members are not satisfied, and this is actually doing what Nist should have done. I want to go back to what you said about how your model looks more like the building as it comes down as opposed to Nist, which, from my own layman point of view, looks like one of those novelty soda cans crinkling in the Spencer shops, as it twists around. I just want you to analyze that a little bit. What did you think you did differently from Nist to achieve that outcome?
Well, it's not completely clear everything that they did for progressive collapse, but here's a couple things that they did do, which affects their result. When they modeled the building, and they only modeled the connections over part of the floor system, and the other part they approximated by what's called pins and joints and fixed joints and so forth. It turns out that the stiffness of within those two areas are quite different. By making that decision to try to simplify computer time, if that's what they were doing, they actually affected the behavior of the structure. And so if you take that idea and you progress it all the way to the 47 stories and begin to look at what happened if you take out some floors or take out some columns and the building starts coming down, you'll notice that part of that building is quite different in looks than the other part of the building, and that's where those stiffness values are changing. What we've done is model the building with connections, and we simulate those connections accurately and put in springs to save the computer time, but those springs act like these true the true connections that are in the building. And when we do that, you're actually going to get a representation that is highly accurate of what that building would be subjected to if you put a load on it. So that's the difference. That's at least one of the differences.
It's just interesting that you can do this and recreate the building, throw it through all these different scenarios. And we're going to talk about different scenarios and ones that you've tried. But first, for the audience, please describe Nist's collapse scenario of what they said happened inside the building to make it look like a controlled demolition, and how you went about trying to simulate it. You've touched on this already, but what steps did you do to try to get that entire internal structure to go down and leave that exterior standing?
I don't know that I'm prepared today to give you all the details of what Nist did. I can tell you how they were looking at column 79 coming down and affecting the floors down below, and the number of floors that were affected and all that kind of stuff. I think there were, I can't remember the number. Maybe just give me a moment here and I can, okay. So the vertical support and lateral restraint at north side of only was about from floor 8 to 13. And then they had lateral supported buckling initiated at over 9 floors. That was their argument of what actually may have happened during the collapse. We attempted to do that same simulation, and we could not get anywhere close to the answers that they were talking about using 2 different computer programs and 2 different individuals trying to accomplish that same task. There was just no way that could have occurred according to our results in our studies. And we've taken a look at things that quite differently than Nist did. We looked at their argument was that the floor was not compositely connected to the girders but did have shear connectors on the beams, and so all of that would affect the behavior. Actually, we found that they did have shear connectors on their girders, but we studied it with shear connectors and without shear connectors, and found there was sufficient friction to enable that thing to behave, particularly since there were shear connectors on the beams, and there's no argument about that. So consequently, the floor stiffness was quite a bit significantly better than they thought it was. And so when you take a look at that massive concrete resistance with the floor system and the beams and the girders all working together as a unit, it's going to take a tremendous amount of effort to get that to start acting like they were suggesting it had to do. Furthermore, what we looked at, what we determined is that they stiffened they've treated the exterior walls as fixed, and that simply just was not the case. So we actually applied the connections that actually were installed in the building as springs and simulated the behavior around the exterior of the building as well as the interior of the building to get the performance. So when it begins to move, there is some resistance to rotation, but not a lot. Furthermore, it's pretty interesting to make sure that if we looked at the concrete floor, it should be connected to the girders and the beams, but not necessarily to the columns. So that we looked at as well to evaluate the potential influence of the floor and the beam girder system and the girder and the column system and how that all interacted. The other thing that we did, which was quite a bit different in terms of behavior, is we actually attempted to go get an understanding of the aggregate that was actually used at the job site. And those aggregates have a certain behavioral characteristic, both thermally as well as mechanically.
And before you continue, what is an aggregate for our audience?
Broken rocks and sand.
Okay.
And they put it into a cement with a cement and water, and they stir it up, and they take it out to the job site, and they place it in a set of forms, and then it begins to harden. And then they use floats to actually float it down. And if it's a trowel finish, they trowel it, and then you get a smooth floor system out of it. Once it's hardened, then it carries load as well. Okay, so then we began to look at the potential ways that this building could come down. Now, keep in mind that we should not forget that we have video of some of the building that as it comes down. There's just no doubt about that. The top 26 stories, we can see everything that's going on around it, at least on one side or two. So if you take our building and you put it there and you subject it to some condition, what happens to your building? And what is it going to take to make that building act like the true building? And so at that point in time, we began to look at alternate methods, alternate things that might have occurred. And lots and lots and lots of people argue that, okay, the interior columns came out first, they went down, and then drug the exterior columns in, and they buckled and folded down upon itself. Well, if you look at the video, that couldn't have happened. And if you look at the video in another sense, there's an exterior surface on that wall system, and that exterior surface is not very structural. So if there's any movement relative from one column to another, one member to another, you're going to see it on the surface of that sheathing, and you just don't see much. And so therefore, that tells you automatically if it's not bending with respect to its neighbor, and it's not moving with respect to its neighbor, then the two neighbors are going down together. And if that's the case, there's no relative displacement between the edges, and which means that there's no warping, and there's no bending, and there's no rippling, and there's no any of that stuff on that surface. That being said, that's telling you that it's a free fall condition. So that's what we're finding right now.
One thing about this whole issue that I think makes it very difficult is the disagreement over certain facts. And I'll use one example. In Nist's report, they claim there was raging fires under these beams that pushed the girder off its seat. But when you look at the actual pictures of an hour before, the fires are out in the area of a collapse initiation. So now this takes it into a realm where it's not just a math problem you give to high school students with, it's 5 plus 7, and this is the answer. One guy does it right and one guy does it wrong. But it's taking in different evidence points, and Nist in my view, was selectively making the evidence, fitting it with the results that they wanted to come to. So how much did that affect your research into this study?
So what we did is we said, okay, we are not going to argue with you about the fires. We'll just take those fires and use them, which is a worse scenario than is truly out there. And if we can't determine the same thing you did with that, then obviously one of us is wrong. And so that's what we did. And we determined a number of things through that process. First of all, we put the fires there, we let it move, and the first thing we discovered is their movement of 5.5 inches when they first said that it moved off and shoved off the support, and that enabled the column 79 to not be braced, and it came buckling down. Well, guess what? They forgot the fact that there was a plate there, a stiffener plate, that prevented it from being able to be shoved off. Secondly, there were a number of factors associated with that whole scenario. They also were looking at the expansion of the girder and of the floor system. And if you really stop and take a look at that, when you heat up a floor, it's going to start moving with respect to the stiffest point. And what Nist did is that they fixed the exterior walls. And when they did that, the floor system moved away from the exterior the wall system, and and therefore it shoved it, and they claimed it shoved it 5.5 inches. They later said it shoved it around I think around 6 inches off of that seat. But again, there was a stiffener there, and it couldn't have happened. But our analysis, we did not lock in that exterior wall. We put the connections that were actually built into the building there, and as well as the rest of it, and let that thing move. And when it moved, it did not move from the exterior wall inward towards column 79. It moved just the opposite. And so we were getting horizontal movements in the neighborhood of 1.2 inches and maybe 2 inches and so forth, not 5.5 and 6 inches. So there's just no way it was going to move off of anything. So that automatically says, okay, what they're saying is not one of those things that could have happened. Now, the next question is to ask yourself, okay, so there was these fires. Really? Where did the combustibles come from? We're talking about fires in floors that much of which were conditions of business or secure information. Don't you think that stuff would have been locked up in files and cases and not out on the desk? And even if it was on the desk, are there enough combustibles to keep that fire raging for that many hours? Just don't think so. So there's just so many issues with respect to what they were coming up with in terms of a solution, and it was not consistent with what was actually built out there. Furthermore, what I did, which was a lot different than I attempted to get the actual aggregate for the floor, dolomite. I looked at the thermal expansion of it, and I wrote a paper about this some years ago of what it takes to expand the concrete with different aggregates, and how that correlates with the steel expansion, and they are different. And so therefore, I saw no evidence where they actually considered the floor system expanding at a different rate than the girders and the beams. So all of that also impacted the end result. So we looked at all those issues very carefully and looked at the possibility of whether the building could actually have come down as they said it was. And I see nothing in our analysis shows that could have even remotely been possible.
Now, you talk about remotely possible. This scenario, this girder getting pushed off its seat and all of these internal failures happening to cause the inside to come down and leave the exterior standing as a shell for a few moments before it comes down, and that's why they say it looks like a controlled demolition, according to them. Can the exterior columns ever still stand if the core columns have failed?
Well, I don't know. I can tell you that we were not able to get that to happen. Our analysis does not show that that's a possibility. We tried to simulate whether they actually buckled inward, as many people argue. We tried to simulate all those conditions, and we used more than one computer program. We even took simpler models to examine the theory behind that whole phenomena, and it became very clear that that was not going to happen. So that means something else is happening, right, to get to what the conditions they saw.
Well, let's get into something else there. First, I want to ask, what other scenarios were plugged into the finite element analysis besides what they were claiming happened?
You mean by them or by us?
By Nist. With the official story, obviously, you want to check that scenario. But what other scenarios? Because there's people that will come out of the woodwork and say, well, maybe Nist got it wrong, but I don't believe it's controlled demolition. Maybe this or that happened instead. They'll throw out theories. What else? What other ideas were looked into?
I don't know that I can be prepared to talk about every little detail that Nist did in that regard today, but I can tell you that we looked at every aspect of what we thought that could happen in that in that scenario. And you got to remember something, that this building is not symmetrical. Because it's not symmetrical, if something happens someplace within the building, it's not going to come straight down. It's going to come down at an angle or rotate or any number of things, because the centroid of that building is not in the middle. It's just not. And so if there's things that are going on that cause it to come straight down, then there's got to be influences to make that happen. And I didn't see a lot of evidence where they were doing a big study about that thought. We have extensively studied that carefully. I'm not going to tell you that it's controlled demolition. I'm going to tell you that we looked at various modes of failure, and in those modes of failure, we have ended up with a result that looks very, very comparable to what the building actually went through when it came down.
Now, in terms of those modes of failure, result that looks like the way that the building come down, could you get into that with our audience?
Well, I can tell you that we took around the I can't remember. We looked at several floor levels of taking out the interior columns, the core columns. And then we delayed the coming down of the exterior columns, and we determined that wasn't what really happened, because the behavior was totally different. The columns, if they were going to fold inward, didn't happen. We tried everything. We looked at the individual column buckling behavior from the bottom of the substation all the way to the top, looked at various aspects of every single column to try to understand what it would take to do what many people think it did. We couldn't ever get it to do those things. So then we started looking at severing the exterior columns as well. And when we began to do that, then the behavior of the system begins to look a lot like and I'm talking about after or just simultaneously to the interior columns. Then you're getting a behavior that's very, very similar to what you see in the video.
What could cause those columns to sever in those moments? What natural phenomenon do you think could cause that many core columns to just break at the same time to give us what we saw that day?
I don't believe there is a natural phenomenon that's going to do that.
Well, I will let our audience draw their own conclusions from that statement. Obviously, the report is going to be coming out very soon. By the end of the year, they can look into this in more detail when it does come out. What's next? I mean, you touched on this before, But when you're all completed, all the work is done, you said it's going to be published as a paper. Please describe that process for our audience so they can know what to expect.
I don't believe it's going to be one paper. I think it's going to be several papers. Before I get there, let me talk about something else that's really kind of an important idea here. If it truly was fire, as Nist believes it is, or say that they believe it to be, then there had to be a professional responsibility to change the codes so that we, as engineers, structural engineers of record, can prevent a failure like this in the future. Yet nothing like that was done to my knowledge. Secondly, if it was not fire and it was something else, then there's a responsibility to make people aware of what really did truly happen. And I don't see that evidence either. So if there was a fire issue, then there had to be a responsibility to changing and updating the codes to protect against future fire damages. But if you go back and you look in history and take a look at the number of buildings that come down because of fire, there aren't any. So at the end of the day, that gives you some indication of the fact that this building, there's more questions than there are answers to coming back. Now, coming back to the question you asked, we will probably submit several papers for publication. And right now, my PhD student is working on about 4 papers in his PhD. 3 of those are not related to World Trade Center 7, but they are related to fires and fire testing and fire codes and the fire response and behavior. And then the last one is progressive collapse of this building. I expect there to be at least 4 papers coming out of this. And I'm talking about in respected journals around the country. I'm not overly optimistic that they will be published in this country. I'm probably going to submit them in Europe or someplace like that where people are more receptive to reviewing them scientifically, and maybe there won't be as much politics involved in what may or may not have happened here.
Yeah, to me, from what I've experienced, it's not even just a question of science, it's a question of politics and psychology, too, because a lot of what holds people back from actually doing a fair analysis is preconceived notions that they won't let go of. But I do want to see this out around the world. I know the difficulties that we face here in the United States and getting information about this building out. What kind of challenges do you expect that you will find when the paper is published? What do you anticipate are the criticisms or problems that people are going to try to find with the work?
I don't even know. I don't know that there could be too many challenges if it's published in a respected peer-reviewed journal, because those were supposed to be scientists that review it and have agreed that the science is correct. If people start criticizing that work, then I guess an approach is to say, okay, show me where there's problems. Show me why yours is better. Show me what you can do to prove that something is different than what we said it is.
That is how science works. That is how we come to truth, and I think that is the best answer that I could have heard. You're a teacher, and you have to deal with students throughout the year, and you talk to them about the profession that they want to take on, a very important profession. Every time we step in a building, we see the good work of people like Dr. Halsey here. As the building doesn't come down, they're very sturdy and last for years, and that requires a lot of education. What particular ramifications for the engineering community and your students going into their careers will this study and this issue have, in your view?
Well, I think somewhere along the way, we've got to come to a realization that it was either a fire or it wasn't. And if it's a fire, then the code needs to change. If it wasn't, if it was a fire failure, then the code needs to change. If it was not, then say that and get on with the business at hand. And we move on and we fire protect the buildings just like we have always, or do a little better job, but at least realize that it's going to take a lot to have a problem.
Now, Dr. Halsey, I think that is a very good update. You gave us your time frame. You told us some about what your findings were. I just want to know now, do you have any final thoughts or anything that you want to get out there to the audience that I didn't think to ask you today?
Well, I don't know how well we're going to be able to do this, but I'll give you, it's my intention right now to show the building video as it's coming down. And beside of it, our failure, our anticipated failure type, with our building coming down in the same framework of the video, so you can see it coming down in the period and the time it takes for it to come down and the way it comes down. Comparison one by one, those two side by side. That's what I want to show. And if this is really very, very good, and I anticipate it to be really good, then the layman can see without having to worry about the science. Here's what our analysis shows. Here's what the building did.
Well, that is going to be available for everybody to see. I know there's going to be a lot of interest in this. So when we have the video, we'll direct everybody to it. Dr. Halsey, I know it's been a long time you've been at this. Believe me, I know what it's like to be on projects for a number of years and be coming towards the completion of it. I'm working on one right now. So I appreciate all the hard work that you and your students have put into this. Looking forward to the results. And thank you so much for coming on 9/11 Freefall.
You betcha. You have a good evening and a good day.
This program is on every Thursday night on No Lies Radio at 10 o'clock Eastern, 7 o'clock Pacific. You can also keep track of the archives by going to 911freefall.com. This is Andy Steele saying have a great week and good luck.